Okay, so now the meeting is being recorded. All right, so here we are, continuing down our Lunchbox series for advanced data modeling. This is supposed to be session 6 of 9. We're up on the Earth Day, the 22nd. We never completed module 4. It was such a large module. So today we're actually going to complete module 4, and then we'll hopefully get to the lab. So we're going to kind of continue to shift this down a little bit. So this may be session 6 of 10 now. We'll have to see if we add one more to it. Again, we use Slack to communicate. Let me grab the invite real quick. And I will put that out in chat. I'll have chat open on my other screen in case you guys. All right, why didn't you? Oh, geez. Now it's in there 5 times. My computer is a little bit slow. I think it's wanting to do its reboot or whatever. So hopefully we won't have too many issues. All right, so there's the invite. If you're not in the Slack, please get into Slack, and that's where we kind of share information, especially like this new Zoom link that we were talking about earlier. All right, so back into our PowerPoint. We finished up with a demo on measures and what measures are. Where am I at on this side? Sorry, I don't know how I got lost in my presentation here. I am at, this is right there. All right. So let's continue talking about measures, right? So it's going to kind of get into sophisticate or simplifying or different measure scenarios. So here we're looking case 1 using one measure within another. So this is going to subtract the. This is interesting. Oh, okay.
Cost of goods
Okay.
sold.
Yeah. So what this is showing, right, is if you're trying to come up with your profit, if total cost of goods sold, you already have a measure, right, that is defined like this, right, then use that instead of redefining the statement again, right? So that's reusing the measures and having dependencies on them. It makes these formulas simpler to read, right? And then this way, if something changes, you don't have multiple places that you'd have to go change this calculation, right? So when it's sum and it's pretty simple, it's easy, but referencing other measures is a good best practice and a way to simplify it. So that's what this is communicating. Here's another example. When you have a little bit more complexity, there's 2 ways of doing divide. You could use the slash for doing the divide, or you could use the divide function. The best practice is to use the divide function because it has error handling built in, right? So if total sales happens to be 0 for some reason, this top one would throw an error and you would have an issue on your visualizations using it. Where this one would just return blank. And I'm pretty sure on divide, you also have an option, a third option here, that you could tell it what you want to return when there is an error. Definitely, I would say prefer this one. There could be a performance change, but you'd have to be on a huge model to see that. The SQL BI guys just put out another video within the last week or 2 talking about this exact scenario and maybe times that it is good to go to this, but it's kind of few and far between. As you get into more complex measures, use variables, right? So think about a variable. You could think of it in two ways, as a constant, or as kind of like for people that came from a SQL world, you could also think about like this one for sure is like a temporary table, right? If you think of how you could write in SQL that you could push something into a temp table, that's what this one is doing here, because the filter function returns a table. And so breaking down this part of the calculation, this first is going to remove every filter on the column campaign DIM device. And then it's going to filter it to only include mobile. And then it returns a table, and that table is just going to be a single column table that is basically campaign DIM device without mobile in it, or with only mobile in it. It's just going to be one, assuming that mobile is distinct inside there, it's going to be one row, one column. So that's, but it is as a table object. Then this is going to call the function of same period last year to modify the dates. Again, it's going to return a table. So this is another kind of temporary table. Oops. And then both of those will be used as filters in Calculate. So now Calculate is going to do this sum of total sales. I'm going to turn that that prompt off. I don't know. Do you guys hear whenever somebody comes in and out?
We do. It's fun.
Okay.
It's like watching Twitch, and then like people are scoring points or something. I don't know.
Okay, I'll leave it there. I had it turned on so that I could tell if first person that joined, but as people come in that or leave, that's gonna ding. But since I'm in, having fun. So now it's passing these two tables, kind of temporary tables, as filters to this calculate function to filter sales for the sales amount.
So let me, because you mentioned that it'll, like the first one, it gives you a table with one column. And it needs a table. Like if you gave it a column, is that a thing? Like, is there a difference between a table with one column or a column? Or that's really DAX will just sort of take care of the difference between them?
No, there's definitely a difference. But we tend to think more in tables within the Power BI engines, right, than we do just with particular columns, right? So this part here could have been written differently down in this calculate, where I could have substituted this to just say campaign DIM device equal mobile. I could have put this part there. Now,
would that take care of the all part as well? Like, would that replicate the logic?
Yeah. Yes, because in the calculate, it overrides when you tell it a particular column, it will override any other filter on that column as well. That's part of Calculate's functionality.
Thank you. Great.
Okay, so I think we've covered this a couple times, right? Calculated columns versus measures and when to use what you want, right? Hopefully we've covered this, but we'll kind of say it again. What's in green, the calculated column, right, is when you need that value in a slicer or you need it in the rows, right? The rows or like the axis of the visualization, right? So this is an axis and this is an axis. So these need to actually be columns, either calculated columns that you produce from DAX or columns you bring in from Power Query, but you cannot use measures on the axis of your visualizations or within your slicers. The values that you want within your visualization, those are measures. And so that's what's all highlighted in red here.
This is a great visual. I mean, we talked about this, but it's great to see it laid out like this. I think it's great reinforcement.
Mm-hmm. Yep. Okay, so now we'll start getting into a little bit more advanced parts of the evaluation context, and hopefully I can do this justice. Okay, so DAX has two types of functions, right? It could bring back a single value, the scale of your function, or it could bring back tables, right? List of right? It's going to have a whole bunch of rows as your output. Okay. So when it's a single value, that's basically a measure, right? Because it's going to be a single value that's going to sit within the intersection of everything that you're doing within your visual, like the intersection of your axis, intersection. It's easier to think of in a matrix or, yeah, definitely in a matrix where you have rows and columns. That intersection is going to end up being a particular value, and that's a measure, which is a single value. Where the tables is kind of DAX's query functionality. Again, trying to relate it a little bit to something like SQL or whatever. You could run a query against DAX and it returns tables. All geography, right, is going to return the entire table of geography. The DAX calculations are evaluated under two different contexts, a row by row context and a filtering context. So like when you're doing a calculated column, the calculation for that column is being evaluated in the row context going through the table. So that's the easiest way to think about your row context, is definitely in a calculated column. So in this example, we have whatever table this is, and it's saying it's in the sales table. It's producing a column called COGS. It's going to be equal to a related column. So there has to be some relationship from sales to product to get unit cost times the sales units that's right in sales. That's going to execute on every one of these rows independently. Looks like they kind of named this incorrectly because they got COGS C or whatever. But that's right. So it's going to take this one, go look up the unit cost on product, multiply one. I'm assuming that was 21 to come out with 21 over there.
I mean, can I just ask, if the cardinality is not right and there's not one particular unit cost because, you know, the way you built your thing, does it generate an error? What does it do if it can't find a single unit cost for that row?
Yeah, that will generate an error, right? Especially with this related, right? It definitely won't work. Or if you're trying to do something else, because again, you could put anything in here that you want for your expression. So you could even calculate another measure or whatever, and we'll see if it gets into that next. But yeah, if it can't resolve this to be one value, then you're going to end up with an error. Because definitely the calculated column, right? It's got to have one particular value to put on that row. It can't expand the rows out. Okay, so then filter context, right? And filter context is, we see that a whole lot in Calculate. So we tend to think of that in Calculate or when we're producing our measures. But here's an example of the filter context. So we have a measure that is just sum of total sales. The filter context to produce this this number, the 3,284, is filtered by Q1, H1, Hawaii for the state, and years, right? So all the filtering from a visual is happening from what you're seeing on the visual. That becomes that translates to the filter context for this measure for this cell, right? This cell has a different filter context. It would be Q2 instead of Q1. So it's coordinated throughout each, in this example, right? It's easy to think again by cells. Each one, it has its own context. For the total, right? In this case, you no longer have a filter context for the quarters when you get to the total. It's just the filter context for the state, which happens to be blank. Or if we pick Vermont, this 7,436, its filter context is the state of Vermont for all of these quarters, which would then calculate this value, right? And that's important to know because sometimes you could have measures that you could end up with you see a different number on the total than you added up across here. And that's because of something you're doing within your measure, because this isn't just simply adding this up to come up with a total. It's a whole nother, it's another execution of that measure with this filter context. Okay. This is one way to think about it in terms of coordinates like latitude and longitude, right? This is the coordinates for this cell, and it also has this additional filter context from this outside visual.
Is it a bad sign when you're looking at something you built and you want it to just add up the things that are showing or it's whatever, and you're like, why can't I just tell it to do that? Does that mean like you're not thinking, I'm not thinking right about how to build? Clearly I'm not, but it just seems like a gap, like for me. Like,
well, as you build more complicated measures, then that becomes, right, that could either signal an issue in your measure, or it could signal that what you're doing isn't really additive across, right? So either one could be correct. You could have a problem. Sometimes you have to put special logic in to know what's in scope, to know how you want to handle your totals.
Oh yeah.
or you turn the totals off in your visual if you decided that the totals are invalid. That's perfectly acceptable because there's things that you're not showing something that would actually total across, and so you could turn them off.
Yeah.
Okay, so filter context in this scenario, right? It's really just kind of switching. We got the exact same kind of the exact same measure, right? And the filter context here is the year is 2015 and quarter is Q1, right? So again, this is the intersection, the latitude and longitude of what's being calculated on this measure at this time. And on this one, it just changes to Q2. It's got the same thing, right? So you could see how your other visuals, like your slicers, or if you're picking something with the interactions, right? It provides that filter context over to your calculation. Is there a question? Okay, thanks. Yeah, so here, what they're trying to tell you, right, is the bottom line is right, the definition of the measure when you're developing your measures, right, you're actually developing just a snippet of the code that's going to be executed and reused. Somebody is kind of making some noise. If you could put yourself on mute if you need to, I'd appreciate it.
Oh, I'm sorry. I'm putting on mute.
Thank you. So this is where it's adding, right, this under a filter context is, right, that's your full definition of when the measure is being executed. It's doing your sum of sales amount under the filter context that's provided from the rest of your visuals, right? All the visuals that are on the screen or within the interaction. Okay, and one thing I would add to that, right, is those filter contexts require a relationship in order to do that filtering. So it's also based on the active relationship. So maybe here, this is what we're going to get a little bit into. Yeah, because here we're talking about, right, where the reason this slicer works to filter this visual for this, for the measure is because we have this relationship that is a one-to-many with the arrow going towards sales, and we're doing our calculation off of sales. So therefore, the date dimension filtered down to a particular year will filter sales off of this relationship.
So this, well, maybe, I mean, it's going to say it right here about the bidirectional. That's what I was going to ask about. I guess you want to keep going. Sorry.
Yeah, well, all it says here is just a very generic part of bidirectional would mean that if you're selecting something off of this, it's going to filter back to this table. Bidirectional filters, I would just caution is to make sure you know why you're using them, right? It's not, it's an exception, not a norm, but there are some cases that you can use them. They will increase your performance, and they could end up giving incorrect results, or worse off, they could give, there could be ambiguity across how you're getting to particular tables. And once it introduces ambiguity, you could even come out with incorrect results. I could find, again, the guys from SQL BI did a great video that did a deep dive into ambiguity. And so it kind of talked about bidirectional filters with that. I'll see if I could find it and put it into Slack later on.
Maybe that's why my Power BI keeps crashing.
Yeah, I mean, if you just kind of do it all and you put a lot of bidirectional filters in there, you're going to increase the size of your model and you're going to end up having trouble.
Kevin,
right. Yeah.
I was working on something once where I wanted to, ultimately what I needed to do was a left join, but when I did the one-to-many, I guess maybe, does that automatically do an inner join when you do the one-to-many?
No, when you do the one-to-many, it automatically does a left join, right? And that's where you get the blank value, right? Because Power BI or the tabular model in general, when it can't resolve a relationship, it automatically adds blanks to that side.
That's what I thought, but I was only getting matches for the tables. So I went into Power Query and I merged it as a left join and it worked just fine. So I don't know, it must have been something else. So you cleared it up. If it's automatically a left join, that's what I was thinking. It should.
Yeah, left outer join though. It should introduce it. I had the same thing, Tom. I didn't figure it out. Like I thought I would get blanks. I was doing some join in Power BI and I thought I would get blanks for the things that didn't match.
It threw me for a loop. Yeah.
Yeah, I still don't know what's wrong. Yeah, I guess I'd have to go back to, like you did, go back to Power Query and fix it. It's weird. I don't know.
Yeah, because I know, because I just sat in Phil's session last night again, and he was kind of doing DAX for SQL people, and he covered that again and just said, everything is considered a left join, the way that the engine does it. So I guess I'd have to see the particular setup that you were doing and maybe be able to help explain it. So if we want to do that at some time, just kind of reach out to me.
Or we could do it on May the 4th.
May the 4th, we actually have a speaker. So.
All right.
Maybe afterwards, right? She'll take about an hour. So anyway. Okay, so I don't think I actually covered this slide. We had it up and then we got with the other question. So this is showing you what you'll see when you have a bidirectional filter, right? So now what this will do is if you have a filter on the date dimension, it will flow through sales and actually also filter customer, which means that if I did a query against the customer DIM, and let's say I'm just going to do it in DAX Studio and say, I want to do an evaluation of customer DIM, which is just basically a select asterisk from customer DIM. And then I provided a filter where date equal to a particular date. Because this will filter through that, this would be that filter would work through these relationships, and it would give me customers that had sales on that particular day. But from customer over to date, customer does not filter date down. But you could get this. This would be a use case. You would end up getting customers that had sales on a particular day doing that. I hope that helped. I hope I explained it pretty well. Okay, so this is just in fact, see, this is, without me even reading ahead, I get an idea of what it's trying to do. One of these days I'll remember I'm doing this and read ahead of time. So, right, it's showing it is filtering through. And it's showing here that I have in this month I have this many total sales. And when it's doing a count of customer ID, which is, going to be unique in this customer dimension, this is the number of customers that had sales in the month of January. Same thing through every single month. Okay. And here it's talking again, why can't I just enable all bidirectional? They are expensive. And so you only want to turn it on when it's absolutely necessary. One of the techniques that a lot of people will end up using is you might not want to leave this on because either it introduces ambiguity into your model or there's other things that will cause performance reasons. So one of the things that you could do is you could get your values of customer ID off of sales, and values will give you your distinct list of customer IDs. And then you can just do count rows on that and you'd get the same result without having the bidirectional filter. You can write a measure that does it that way. And then you're only taking on that extra expense at the time that you need that measure, to where you maybe take it on extra expense here when you're doing other just regular measures as well, depending on what the engine decides to do. Okay. But here, because of we only are filtering one way, right? You can see what they changed is they put customer ID in the table itself. So I'm getting now sales by customer, and what they were trying to do is say, well, how many months did each customer buy something in? And we don't get that. We get the same value all the way through because it's going to return a value, but there's no filtering that's happening over here. So this filter isn't propagated across, so I'm always going to get 12, right? Because the assumption also here is I'm getting 12 because I'm filtering down to a particular year, right? If I didn't have any other filter on the dimension table, I'd get my full count of all the rows in the date dim. I don't know who Barbara's blog is, so.
What's Barbara's blog?
If you see the notes down at the bottom, it says see Barbara's blog on the many-to-many using keywords. Also note there's a custom keyword text filter. I don't know. I didn't research what they were trying to point out there. All right, so we'll get into evaluation context and multiple tables. The row context of when you're having things run within a row context does not propagate automatically. You need to use the related or related table functions in order to go from, right? So that was our idea of going, whatever was early on, what was that, the sales table, right? And saying go related to the other one, right? To the product table, we had to use related. As you get deeper into it, there's a concept of this extended table. And so what you could think about is when you're on a row within a particular table, you have access to all of the other tables that it relates to as this extended table. And the related function is what allows you to get to those columns on the extended table.
Kind of like if you joined your, if you join the table you're in with all these other tables and you restrict, you know, where clause restricted it to just that row you're in, and then it would just pick out from that join of all the other tables what was connected to that one row. And it could be a whole bunch of rows, right? That's what you're talking about, the extended table?
Well, the extended table, more like if you start from your fact table, right? More than likely, it's just going to be, right? Because your fact table is the many side always. It's just going to be that one going out, right? But yeah, if the table has a relationship that if you're going from that to a many side, then you need to use your related table, and you might need to filter that other table down or do something like if you're producing a calculated column that you need to get down to one value, you might need to reduce that down through some type of measure. Say you get the first or the min or the max or something like that.
Right, okay.
Yeah. Filter context propagates automatically through your relationships. And it depends on the relationship arrow inside your diagram, right, for which way that it's going. Okay. It's a very, very deep dive. I think we talked about getting deeper into DAX in one of the next Lunchbox series, right? And we could get even more into what's going to happen in this area. Okay, so why would you end up using table functions within Power BI Desktop, right? Because if you're producing a measure, the measure itself has to return one and only one single value. But you might end up needing to use tables or temporary tables, right, in order to achieve that result, okay? So you might end up trying to produce a table that's an input to calculate, or it's an input to the iterator functions, right? Just kind of a reminder of what the iterator functions are. Sum, and you give it a column name, we'll sum up that entire column name. And that's what some people call syntax sugar for the sum X. The sum X is the iterator part of it, where the first parameter it takes in is the table, and then the second parameter is what it's adding up from the table. So the iterator function getting a table, that's why you could put in a function that returns a table like filter to say what's going, you know, to show, or I'm sorry, to produce that measure. Or you might end up producing calculated tables within DAX itself, right? You're going to produce a calculated table like a calculated column. So you're going to write table functions in order to populate that.
To some extent, does that stuff, some of this stuff exists because did DAX exist in Power BI before there was a Power Query phase before it? So people were doing a lot more data shaping within the, or is it just not related? And it's just weird. There's an overlap, right, to where you can do stuff.
There's a little bit of overlap. I would agree with you on that, right? But you know, Power Query would have been developed by one team. DAX would have been developed by another team. Some of this existed inside Excel before Power BI came on. One of the things I heard in the summit that I've been attending this week, and I didn't realize, is this is really like the third iteration of Power BI, right? They had stuff that they didn't even call it Power BI early on, that they had kind of the same direction, but they actually failed at able to roll it out correctly. And I think it was that Silverlight or whatever was kind of one generation of all of this. And then they learned from those mistakes. They started doing things again and they didn't like it. They threw it all away and then they finally re-architected and came up with this. But that doesn't mean they didn't have a project for Power Query kind of going on, because Power Query is not only in Power BI desktop, it's in Excel. It's now over in a couple other areas as well. So they looked at it from its own project, and then how they bundle things together. DAX
Okay.
is kind of the same thing. Yep.
Okay, so yeah, that I mean, that makes sense. It means that they were putting things in DAX, not really planning. They kind of aware of Power Query, but also just saying we want DAX to have all this functionality, and so we're not going to depend on it being provided by another tool. So there's
Right.
a lot of stuff. That's why DAX has so much in it.
Yeah, and sometimes there's things that you could do honestly easier in DAX than you can in Power Query, right? Or there's things that you could do. We just reviewed a report with one of the developers this morning, and we're using the direct query to Power BI data sets, or actually to the models. And so you don't have access to that through Power Query, right? But he needed to put a calculated column on something. Now he could do that because of this new functionality, and he does the adding a column through DAX rather than through Power Query. So sometimes it depends on your use case and what you're connecting to on where you need to be able to do it.
Right, that makes sense.
Okay, so some basic table functions. All and its variants, right? So says we'll discuss these three classes later. So return all rows. There's all selected. It gets a little bit confusing. One of the things I did here recently too is that they haven't done their best job naming the functions to what they do sometimes. But we'll try to, that's why the documentation comes in quite a bit. So returning distinct rows. I'm not sure how we get distinct rows from all, but we use distinct values. We'll return distinct values within a column. I think like if you give it all in like a column name, it gives the distinct rows within that column. And then if you want to do filter, you could use the filter function. There's also a calculate table function that is very similar. And a lot of times you can replace one without the other, just depending on the way you like to write your things. So like here, all with the entire table. So all over with the entire table. It's going to remove any filters that are currently on this table and give you every single row. All with one column, right, is going to return all unique values of this column. And then all with multiple columns, right? So all is a very specialized function, I think, by the way, because it takes these different things in. All with these two columns off of this table is going to return you the combinations of those values. And then these could be used, right? You could produce this table and you could use that as a filtering context in the calculate function.
Kevin, remember that example you helped me with where I needed to know in the denominator of calculating an average, how many combinations, and I'm gonna go back and switch it to that third all one to see, because that should work, right? I needed to know how many. I was like doing a total divided by a count, and I'm going to use that third one to get the count and see that she gives me the same thing.
Yeah, it might. Yeah, it might. Yeah, that's probably a good thing to try.
Is there a shorthand of the last example? You have to write geography, dim, region, comma, geography, dim, state. And then if you had another comma, geography, dim, and then whatever that column would be, is there a shorthand to that?
I think syntactically, you could leave the table name off. but that's not considered a best practice because that gets confusing when you're reading the DAX or somebody else has taken on your DAX. The best practice is when you're referencing a column to give it the table name and the column name.
Could you
When you're,
do a,
when you're
I'm sorry.
referencing a measure, just give it the measure name.
if you have a really long table name, can you do all, and then inside they say var TBL equals geography dim, and then do TBL bracket region TL, you know what I mean? Like, could you
No,
rename?
the variables don't work that way.
You can't put it inside it.
Yeah.
Yeah. Okay.
Well, I mean, you
You
could
can put
put
it
them, you
before.
could put them in a lot of different places, but it's not a substitution for a table. It's not like a table alias. That's what you were trying to do is get, like how
Right.
SQL, you
Well,
could give it an alias of just one
yeah.
letter.
Yeah.
Yeah, it's not going to work that way.
Yeah. I mean, maybe we could do it before the all statement. Like if this is in a multi-line, you know what I mean? Like if we're defining DAX up above the all.
I would urge you not to do that, or whoever else is going to pick it up. Best practices exist for a reason, right? And you'll come back to it and you won't remember it. If you stick with the best practice of fully qualify your table names and just use the bracketed for the measures, you're going to be able to read your code and debug it a whole lot faster.
Does anyone feel like Kevin just slapped me?
Yes.
I don't know.
Okay, so the additional formats of all. So there's all except, so return all columns in a table except one or more columns. So you could selectively take columns out for the all except. All selected is going to return with, and this is kind of like one of the weird things, right? So all except is going to take out columns, where all selected is it returns all values in a column selected by users in slicers, right? So it's two different total functionalities. Basically, that's trying to tell you what has been selected by the other slicers with it that's influencing the query.
So that there's that has one selected function. So that basically is checking if all selected, if the count of that is one. And that's because there's some, I think we talked about it at one point. And then you'd know there's only one selected something.
Yeah, and that they might have implemented that a little more efficiently. But conceptually, I think you're right that it's kind of doing it that way. And then all non-blank row, right? So when you have the blank row within your data set, right, it's going to be returned. If you don't want that blank row, you could use this function to get rid of it for you. Okay, so returning distinct rows. And this is there's two ways of doing it. So you could use values, and it's going to give you all the distinct values within the column, and it's going to include the blank rows. Where distinct, it's going to give you those values, but it won't include the blank row. So just know the differences between, they're doing similar things, but just a little bit different, okay?
What is the difference between all and values? They both return the unique values in a column, right?
Yeah, I think you're right. There's probably not much difference. If you say all and you give it a column name, it's going to be the same as just doing values, because that's going to give you, now, I guess what I'd have to do is go look at the documentation, because I think all is going to remove the filters as well, to where values is not going to remove the filters. But I'd have to double check the documentation to be sure.
Okay, thanks.
Mm-hmm. The functions that Amin loves has one value. So it's checking to see, does a particular column have only one value, and it returns the Boolean, yes or no, true or false. And then here, so it's using an if statement. When it's true, it's doing this concatenate. When it's false, it's doing values. Or actually, let's see. When it has one value, it's going to say report
Yeah,
header
because
for
it's the
price
parentheses.
band.
Yeah, they didn't indent the values. It's like they should have indented
Yeah.
values. Yeah.
Yeah, and when it has multiples, it's going to just, the title is going to say overall report. So in this case, it has one value. It's going to get that one value right here. And here they're doing it just a little bit different way. That's kind of, oh,
Kevin, I
this is
just
their
thought of
whole
some,
title. Hang on, let me work through this.
sure.
So this is their title, even though they use the function name in here. They're going to say get the selected value for price band. So they're kind of doing the same thing that they did here. It's going into a variable. Selected value, if there's more than one, by default the alternate result is blank. And so here they're just checking to say if it's blank, then it becomes overall report. Otherwise, they're going to concatenate what was selected with what was up here. So 2 ways of writing the exact same statement. Yes, I think it was Tom. Was that you?
Yeah, Kevin, real quick. Back to that, what I said about the left join on I was bringing in the second table. If that second table has multiple matches for the ones in the first table, then maybe I'm gonna have to incorporate using this has one value. Would that be an instance? Or am I off base?
I'd have to see what you're trying to put together, because a has one value is going to be a true false type of
Yeah.
thing. So, you know, I'd have to think of how your query is kind of going together in order to really figure it out.
Sure thing, thanks.
I hesitate to kind of give an answer without knowing more detail. Okay. We got just about 5 minutes left. So the filter function. So what this is doing here, and it's a very common pattern that you see. This is, okay, so this is interesting because a little bit different than I thought what the pattern was going to be. But what this is doing is, if we kind of break it down, how we just saw the all statement a little while ago, where we say all geography region and geography state. So we know that's going to produce us a table with all the unique values from our geography dim, all of those values, right? And then filter is going to filter this resulting table where geography region equals central. Okay, so that's interesting because these 2 things don't look any different, to where here region should have been central, I guess.
Yeah. The other thing, yeah, I know the stick picture doesn't match.
Yeah.
I'm sorry. I don't have it in my head. It seems like it's an overly complicated way of doing that.
Again, you know, these could just be examples to show you how
Right.
to utilize the function. You may or may not have a business case for doing it this way, but it is, I mean, I could definitely, now that, because I haven't done it like this before, but I could think of places that I would have needed to do it. It could simplify my code. So again, it just depends on what you're trying to do, right? Because this is going to keep all your data lineage, and then you want to pass that as a filter table in the calculate. It could make it easier. So so again, yeah, this picture should have had central, whatever central state showed up here rather than east. So they got a little bit lazy. Okay. So now get into visual building. I think it's going to introduce the lab. So the lab for module 4, you're going to end up creating parameters, which we covered weeks ago. You'll have a dynamic path to the Excel file, dynamic path to CSV, and create custom functions. Let's see what else is all here before we get to the end of it. Well, I got all these slides that just kind of goes through considerations. We'll kind of go through these real quick. And I'm sorry, I got a meeting right at 1 o'clock, so I gotta be able to drop off. And
I
so
think you timed it perfectly. I think you, I don't think,
so
I-
it looks like the lab's going to go back to all of our M code that was covered early on. And this should be covered pretty well inside your module lab scripts as well. Yeah, so go ahead, Amin. We'll wrap it up.
no, I was just saying, you have a meeting at 1, you've taken us right up to the lab, which is for us to do, and then come back next week and talk about. So I think you've timed it perfectly, and you should take a few minutes before your 1 o'clock meeting.
Yeah, that doesn't happen a whole lot for me. All right, let me go ahead and stop the recording.